Hi guys, I'm Mariah and this is our Density Chem 151 group project.
I'm Brittany.
I'm Selena.
Hi, I'm Sarah.
And so I had this slide where you had to calculate volume, and the formula to calculate volume is length times width times height. And then so for block one, I just calculated the length, width, and height. And I got the answer as 4.34 milliliters slash volume. And then for block two, I did the same length times width times height and got the answer of 8.73 milliliters per volume. And then same thing for block three and got the answer of 14.87 milliliters per volume. And then same thing for block four, got the answer as 18.82 milliliters per volume. I also did the density calculation, and that's mass divided by volume. So for block one, I did the mass divided by the volume and got 2.703 grams per milliliters. Block two, the answer was 2.721 per milliliters. And then block three, I got 2.713 grams per milliliters. And then block four, 2.710 grams per milliliters. And then I also did the average for density, which is density 1 plus density 2 plus density 3 plus density 4 equals the answer divided by 4. So before I divided the answer by 4, I got 10.847 grams per milliliters. Then after I divided it and rounded the sig figs, I got 2.712 grams per milliliters.
I did the mass versus volume data. So to figure out which one was the X and Y axis, the X axis is the independent variable, which is manipulated by the experiment. And so in this experiment, that would be the volume, making the Y axis mass. And with the volume as the independent variable and the mass as dependent variable, we can then determine the slope of the graph as the density of the block.
So I made the graph, and I used for the x-axis, I used the volume, which is in milliliters, and for the y-axis, I used the mass, which is in grams. And when I graphed the points, I got the density. And then I used the trend line to see what the equation for the density is. And the equation turned out to be 2.7119 x, and then the r was 1.
And then I got to do the first two bottom questions, and I started off with saying the average density for the line graph is 2.7119, and the density from which we calculated is 2.712. And as you can see, they are slightly different, but that is mostly due to the percent error. And some sources of errors could be either the measurement and calculations error, since measurement isn't something we can control or fix to make it more accurate.
The four density values calculated are all very close, and the values were small because they had the same ones and tenths place. The only difference was in the hundredths and thousandths places.
Then the percent error, to figure that out, we take the theoretical value, minus it by the experimental value, then divide that by the theoretical value, and then times it by 100. So the answer was negative 0.0701%.
And that's our reference page.